What are electric charges? An electric charge is a fundamental property of matter that causes it to experience a force when placed in an electric and magnetic field. There are two types of electric charges, positive and negative. Like charges repel each other while opposite charges attract each other. Electric charge is carried by subatomic particles. For example, electrons carry a negative charge, protons carry a positive charge, neutrons have no charge and they are neutral. The unit of electric charge in the International System of Units is the Coulomb. The charge of a single electron is approximately minus 1.602 10 to the power minus 19 coulombs. Electric charges are quantized, meaning they occur in discrete amounts, and they are conserved, meaning the total charge in an isolated system remains constant. In the diagram, if Q is the quantity of charge in an isolated system, then Q is always equal to N times 1.6 10 to the power minus 19 coulombs, and N is an integer. Fundamental properties of electric charges. The first property is types of charges. There are two types of electric charges, positive and negative. Protons carry positive charges while electrons carry negative charges. Neutrons have no charge and they are neutral. The second property is like charges repel, opposite charges attract. Charges of the same type repel each other while opposite charges attract each other. This is the fundamental principle behind electrostatic forces. Third property is quantization of charge. Electric charge is quantized, meaning it exists in discrete amounts. The smallest unit of charge is the charge of an electron or a proton, which is approximately 1.6 10 to the power minus 19 coulombs. In the diagram, there are 5 positive charges and 3 negative charges. Total charges equal to plus 5 minus 3 equal to plus 2. And total charge equal to 2 into 1.6 10 to the power minus 19 coulombs. Fourth property is conservation of charge. The total charge in an isolated system remains constant. Charges can be transferred from one object to another, but they cannot be created or destroyed. Fifth property is additivity of charge. The total charge of a system is the algebraic sum of all individual charges in the system. For example, if you have charges Q1, Q2 and Q3, the total charges Q is equal to Q1 plus Q2 plus Q3. Sixth property is charge interaction with electric and magnetic fields. Charged particles experience forces when placed in an electric field and moving charges in magnetic fields. This interaction is the basis for many electrical and magnetic phenomena. Note that a static charge does not create any magnetic field, so magnetic field has no effect on a charge. So moving or accelerating charge produces magnetic field around which interact with external magnetic field, and the charge will come under the influence of a force due to a magnetic field. What is Coulomb's law? Coulomb's law states that the magnitude of the electrostatic force F between 2 point charges Q1 and Q2 is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance r between them. The force acts along the line joining the two charges. Mathematically, F is proportional to the product of Q1 and Q2 divided by r square, where F is the magnitude of the force between the charges, r is the distance between the charges. The proportionality constant is called Coulomb's constant, which is equal to 1/4 phi epsilon 0, where epsilon 0 is the permittivity of free space. Note that the force is attractive if the charges are of opposite signs and repulsive if they are of the same sign. The value of free space permittivity equal to 8.8542 10 to the power minus 12 Coulomb square per Newton meter square. The Coulomb's constant K is equal to 8.99 10 to the power 9 Newton meter square per Coulomb square. Force which is repulsive or attractive is always along the line joining center of 2-point charges. When there are multiple charges, force between the charges can be calculated using the principle of superposition. In the diagram, there are 3 positive charges and 1 negative charge. To calculate the net force acting on the charge 1 due to charge 2, 3 and 4, we need to calculate force between charge 1 and 2, force between 1 and 3, and force between 1 and 4. Force is a vector quantity which has both magnitude and direction. Force between like charges is repulsive. Force is considered as positive, and force between unlike charges, that is attractive force, is considered as negative. In the diagram, net force on the charge 1 equal to vector sum of F13 plus F12 plus F14, and in this case magnitude of F14 is negative. With this theoretical background, we shall solve some relevant exercises. Exercise 1. 2 electrons separated by distance R experience a force F. If the distance between them is increased by 2 times, what will be the new force with respect to original force F? In the initial setup, Q1 and Q2 are separated by distance R and force between them is F. In the second setup, distance between Q1 and Q2 is doubled. Force of repulsion in the initial setup equal to F equal to K times Q1 Q2 by R square. To calculate the force in the second setup, substitute R equal to 2R. On simplification, you will get F2 equal to F by 4. Exercise 2. What is the force between 2 small charged spheres having charges of 2 into 10 to the power minus 7 Coulomb and 3 into 10 to the power minus 7 Coulomb with a distance of 30 cm between them? Given values are charge Q1 and Q2 and distance R. Electrostatic force F equal to Q1 Q2 by 4 pi epsilon 0 R square. Substitute the given values in the equation. You will get force F equal to 6 into 10 to the power minus 3 Newton. In the exercise 3, the electrostatic force on a small piece of sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the two spheres? What is the force on the second sphere due to the first? Given values are force F, charges Q1 and Q2 on 2 separate spheres. Use Coulomb's law equation F equal to Q1 Q2 by 4 pi epsilon 0 R square. In the equation, all parameters are known except R. Substituting the values in the equation, you will get the distance between the two spheres R equal to 0.12 meters. Both spheres attract each other with the same force, so the force on the second sphere equal to 0.2 Newton. Exercise 4. There are 4 point charges QA, QB, QC and QD located at the corners of a square ABCD of side 10 cm. What is the force on a charge of 1 microcoulomb placed at the center of the square? The question can be described using the diagram as shown. Given that charges QA, QB, QC and QD are placed at the 4 corners of a square ABCD of side 10 cm and a charge of 1 microcoulomb is placed at point O. The positive charge placed at the center O will experience an equal repulsive force from corners A and C. The repulsive forces are equal because the charges at A and C are equal and they are equidistant from center O. So the net force on the charge at point O is due to charges A and C is equal to 0. Similarly, the charge at the center O will experience attractive force of equal magnitude from charges at the corner B and D. Ultimately, the net force on the charge at the center O is 0. Exercise 5 is for practice. Hope you have got enough information about Coulomb's law and how to apply the equation in scientific calculations. We have reached the end of the video. Please do not forget to subscribe to the channel. Thank you for watching.